Number 5, I will show you guys how to integrate I to the x power. This is really cool, and I wonder if I should ever put this on my calculus 2 final exam. Okay, so here's the trouble. I is for the base. That's no good. We don't like I to be the base. We like e to be the base. It's okay though, we can fix that. This is just e to the natural log of I. This is still going to give us I, and then we are going to multiply this by the x because the x is still there, of course. And look at this. This is now e to the linear functions. When we anti-differentiate this, all we have to do is just e to the x ln I like this, and then divided by the derivative of this, which is the loop chain property. Loop chain is the chain loop backwards. So when we do that, we'll just do 1 over ln I like this. And now the question is that what in the world is ln I? Well, you can check out Dr. Peyam's video. He has an excellent video on this. I'll tell you guys the answer though. ln I, the natural log of I, is just pi over 2i, and then here we have this part. But if you look back here and look back here, you know this is precisely I to the x power. And now we're done, but it's no good because let me tell you, I don't like to be on the bottom. I like to be on the top. To fix this situation, it's not that bad at all. Let's just multiply this by I and also this by I. And as you can see, on the top here, we will have, well, I and I is just -1, so I'll put a negative right here. And then this is 1 over pi over 2, so I can put the 2 on the top as well. And then we have this I, and I times I is the negative, and then we have the pi right here, and then we have the I to the x power. So it's like this. And I'm not going to fix the exponent because this is the answer that Wolfgang Alpha will give us, so I will leave it like that. Of course, you can just add the power and say this is just I to the x plus 1, but no. So we are done right here. So answer, -2i over pi times I to the x power plus c, right? Now, I will show you guys another integral. Integral of I to the x power dx. Maybe you haven't seen this before. If not, check this out. It's going to be super cool. First of all, let me tell you, we are going to write the base I as e. Well, to do so, this is the same as saying e to the natural log of I. And then don't forget, we still have this x. So I'll put the x right here, dx, like that. Well, when we do this way, now we know this is going to give us, well, we have to just divide it by the derivative of this. That's very easy, and keep that. So we have 1 over the derivative of x times ln I is just ln I, namely natural log of I. And then this part stays. I will just write it as e to the x ln I like that. And now, what in the world is natural log? Well, be sure you guys go ask Dr. Peyam. This is going to be pi over 2i. So this is going to be 1 over pi over 2i like this. And look at this. It's the same as that, which is the same as that. So I can write e to the x times ln I as just I to the x power. However, don't think that we are done yet because I don't like to be on the bottom. I like to be on the top. Let me multiply I here and I here so I can really be on the top. Let me multiply by I here and I here so I can really be on the top. And as you can see, right here I times I is negative, and then we can put the 2 on the top as well. Therefore, we have -2, and we have the I here and over pi. And then this right here, we still have the I to the x power, and we are done. And because this is the answer that Wolfgang Alpha will give us, so I'm not going to change the exponent. So this right here is it. Okay, so we have done a lot of practice, so make sure that you guys really watch this video a few times so you can really get a good idea of how to practice. By the way, the PDF to all these questions will be in the description, so be sure you guys go download it and work this out. Next, we are going to integrating I to the x power like this. So we are going to have integral, and for the I right here, we are going to just write it down as e to the natural log of I, because this is still I, and then we have the x right here, and then don't forget the dx. And now to integrate this, of course, we keep this part, which is e to the natural log of x, and the derivative of this part is natural log of I. We have to do the loop chain. We have to divide it by the derivative right here, which is just 1 over natural log of I, like this. Well, what's natural log of I? Ask Dr. Peyam, and we are going to get pi over 2i like this. And then we have this part. Whoops, this is not supposed to be natural log of x. It's supposed to be natural log of I times x. You see, this is why we have to do the integral at least 100 times. Otherwise, we'll still be making mistakes. That's bad. That's no good. That's dangerous. This right here, it's horrible because x is on top of the e. Oh man, so better. E to the x times ln is this, which is just that. So I will just put this down as I to the x power. We are almost done, but I don't like to be on the bottom. I don't know about you. I like to be on the top though. So let me multiply by I right here. Therefore, you will see that this is negative 1, and you can put it on the top. You can also put the 2 on the top, so we get negative 2i over pi. And then we have the I right here already, and then this is I to the x power, and we are done. So we'll put a plus c like this, and then we are done. Okay, so told you guys this is review for you guys, right? It's not that bad at all. Now let's go ahead and integrate I to the x power dx. If you guys would like, you can pause the video and try it first. And now let me show you how to do this. First of all, keep in mind we don't like to have I for the base. We like to have e for the base. To fix that, we'll just write this down as e to the natural log of I. If you have 2, you can always write it as e to the natural log of 2. But here we have I, so we just write it as e to the ln I. And then right here we have x, so just put the x down right here. Put the x down. And then this is equal to, well, this right here is nice. We can just get that because it's e to the linear function like this. So we'll just write it as e to the x times ln I. But don't forget to do the Luchet. Divided by the derivative of this, which is just ln I. So I'll just put on 1 over ln I like this. But what is this? Let me tell you, this is equal to pi over 2 because I watched Dr. Peyam's video, so I know what's going on right here. So we have this, and now this part is just equal to this, which is just equal to that. So I will just put down I to the x power. And I don't like to be on the bottom. I like to be on the top. I'll multiply by I here, and as you can see, this is going to produce negative 1. And we can put it on the top. And I can also put a 2 on the top, so this is negative 2i over pi. And then here we have I to the x power, just like this. And then with that, we are done. Now, hopefully you guys are still doing well. Number 9 right here. We are going to be integrating I to the x power dx. Well, we are going to write the I as e to the ln i's power. And then don't forget we still have the x. And then we have to put on the dx. If you don't put on the dx, it's bad. Okay? It's immoral to not have the dx. All right, so we have this, and then we are going to have, well, we have this part because that's just a linear function, so e to the x ln I, and then we have to divide it by the derivative of this, which is just 1 over ln I, right? After you divide the natural log of I. Well, what's natural log of I? Natural, right? You put the cheese, you put the things, natural, right? Natural log of I, Dr. Peyam will tell you that's pi over 2i. So this is 1 over pi over 2i. And then this part is the same as that, which is the same as that. So that's the same as I to the x power like this. But I don't like to be on the bottom. I like to be on the top. So let me multiply this and that. And as you can see, this right here will give us negative 1. And that's 2. I can bring the 2 up. So negative and 2 together on the top. And then we have the I right here. And then we have the pi on the bottom. I on the top, pi on the bottom. And then we have I to the x power like this. And I'm just going to leave the answer like this because this is the answer that the Wolfram Alpha will give us. So that is legitimate. So this is great. Now, number 10. Let's do something special. Number 10. Integral of I to the x power dx in blue. Well, to do this, we know that I is the same as e to the ln pi i's power. So I will write it as e to the ln I. And don't forget we still have the x. And then we have the dx like this. And then when we integrate this, as you can see, this is just e to the linear function like this. So we can just have e to the x ln i's power. And don't forget to do the Luchet. We have to divide it by the derivative of x ln I, which is going to give us 1 over ln I. And this right here is a natural log of I. And Dr. Peyam will tell you that's pi over 2i. So you will see this is 1 over pi over 2 right here, and then the I for the natural log of I. And then this right here is the same as that, which is the same as that. So we know that's the same as I to the x power. But the problem right here is that I don't like to be on the bottom, I like to be on the top. So let me multiply the top and bottom by I. I times I is I squared, which is negative 1. I can put the negative on the top, and I can also put a 2 on the top. All in all, we can get negative 2i over pi, and then we have the I to the x power next to it. I'm not going to do anything with the exponents because this is the answer that Wolfram Alpha will give us. So this right here is it. We'll put a plus C like that. Cool. So that was special. Number 10. Now, getting back to a reality. Number 11. We have to do the hard work, integrating I to the x power dx. Well, for this one, as we can see, we have I for the base. We don't like that. We like to have E for the base. So let's go ahead and write it as E to the ln i's power. This is still I. And now we have the base being E. Don't forget we still have the x, so let's put the x down right here. And then we have the dx. And now, to integrate this, of course, we get E to the x ln x and ln x. Sorry, E to the x ln I. And then we have to divide it by the derivative of this, which is going to be just that, which is 1 over natural log of I. And now, natural log of I, Dr. Peyam will tell you that's pi over 2i. So here we have 1 over pi over 2i. And then this right here is the same as that, which is the same as that, which is just I to the x power. So let's put that down right here. And now the problem is that it seems that we're done, but I don't like to be on the bottom, so we're not done yet. Multiply I and I, so I can be on the top. So as you can see now, this times that is I squared, which is -1. I'll put a negative on the top, and then the 2 can be also brought it to the top as well. All in all, we get -2i over pi. And then this right here, we have the I to the x power, and then of course we're done. So put a plus C right here, and we are done. Okay, number 12. Let's see. What can we do? What's on the... I forgot my PDF. I forgot my printout. So I'm going to just make an integral so we can continue. So let's see. We are going to integrate I to the x power like this. Okay, I is I for the base. No good. We like to have E. So this is the integral of E to the natural log of I. That would be much better. And then don't forget we still have the x right here. And then we have dx, of course. So let's put on dx right here. And as you can see, we have e to the linear function. So when we do that, we get e to the x ln I. And we have to divide it by the derivative of this, which is just 1 over I. So we put on 1 over natural log of I. And Dr. Peyam will tell us natural log of I is just pi over 2i. And that's, again, just one answer, which is good enough for our video purpose. So here we have pi over 2i. And this right here is the same as that, which is the same as I to the x power. Excellent. So now we have I to the x power. But the problem now is I don't like to be on the bottom. I don't know about you, but I don't like to be on the bottom. Let me multiply I and I right here and here. This is going to give me -1, and I will also bring the 2 to the top. So all in all, we get -2i over pi, right? We have the pi right here, and then we have the I to the x power here, and then we put plus C like that. And this is the answer that Wolfram Alpha will give us. So this right here is legitimate. Hopefully it gets all like this. And now we'll continue to number 13. Whew, very, very cool, isn't it? So seriously, if you guys are still watching, I really, really appreciate it. Really, really appreciate it. And again, you can leave a comment down below and let me know what integrals should we be doing in the future. But don't torture me, all right? Unless you buy me coffee, Gatorade, and all that. Buy me tons of markers. And I am still using the markers from the previous video, so you will see if they are still good for this video or not. I think that was 12 or 13. Number 13, I think. Okay, just in case. I know I forgot if that was 13 or 12. I will do number 12. If I did number 12 over there, oh, you guys have another one. Anyway, for number 12, we're going to be integrating I to the x power dx. And now, here is the deal. I will tell you guys the following. Here is the note. And if you guys remember this, it's going to be so beneficial. Alright? So, yes, you can always write the I as e to some ln power. That's fine. But you can also look at this right here. So put on a note right here for you guys. Integrating, if you have b to the x power dx. This right here, you just keep the exponential part, which is just b to the x power but you will have to divide it by natural log of b. So you get 1 over natural log of b like this. And of course, if I don't put down plus c, people will be mad at me and people will click away. That's no good. So I will put down plus c right here for you guys. So this right here, it's a really cool concept. And now I'll be using this for integrating number 12. I right here, so I in our case is the b. So we have to just quote this formula. So we get 1 over natural log of I. This is still legitimate. And then you don't forget to multiply the I to the x power. We're not completely done yet, so I will just put on the plus c at the very end. Well, because now we have to look at what's natural log of I. Natural log of I, Dr. Pan will tell you that's pi over 2i. So now let me just put that down. This is 1 over pi over 2i. And then we have the I to the x power like that. It seems that we're all done, but it's not because we have the I on the bottom, and I don't like to be on the bottom. I like to be on the top. Let's multiply the top and bottom by I. I times I is I squared, which is -1. I will put the 2 on the top as well. All in all, we get -2. And then the I is right here over this pi. And I times I is the -1 right here already. And then we have the I to the x power like this. And in fact, this is the answer that Wolfram Alpha will give you as well. And then we are all done. So let's put a plus c like this. Right? So we are done. Now, number 13. We are going to integrate I to the x power dx. Well, let me tell you guys, there's a formula because right here we have a number. I is technically a number. It's a complex number. Well, a number to an x power. What we can do is, this right here is just going to be 1 over natural log of whatever this number is, which is just I. And then we have to just keep the exponential part. So we have 1 over natural log of I times I to the x power. That's it. But we have to ask Dr. Peyam what natural log of I is. Let me see if he is available right now or not. And if he is, I will just put him on the phone and I will see. If he's not, then I don't know. I will have to ask him to see what L and I is. So let's let's make a call to Dr. Peyam. Yeah, that's me, by the way. That's the laptop.
Hey, what's up?
Hey, Peyam.
Hey,
I'm recording, and you're on speakerphone because I'm in need of figuring out what L and I is.
Ellen of I. Okay.
Yeah, I'm stuck.
Ooh.
I'm not.
Well, there is a video that I've done.
No, I just need the answer. Can you tell me what L and I is?
Okay, Ellen of I is let's see. Well, I is ei pi over 2. So I think the answer is just I pi over 2.
Oh, okay.
Plus 2 pi I. Let me plus.
Oh, okay. I will just take it as okay, pi over 2. Okay, that's all I need. I'm just going to use pi over 2i. I'm on question number 13.
Yes.
I'm on question number 13, and then I have to integrate I to the x power, and then I have like 87 more to go.
Oh my god. Good luck. I mean, the night is young, right?
Yeah. So yeah, would you like to tell the viewer to subscribe to your channel?
Yes. If you want to see lots of exciting math, please make sure to subscribe to my channel.
Dr.
It'll make
Peyam.
you go, whoa!
Whoa! And then the link will be in the description. Thank you so much, Dr. Peyam. Thank you for your time. And I have to continue. I want to go home by 9:30, but I don't know if I can. Anyway, I'll see you later.
Good luck. Remember,
Thank you.
Bruce Lee is with you.
Thank you. Bye.
Goodbye.
Okay, thanks to Dr. Peyam, we know that this right here is pi over 2i, and then he was saying you added like 2 pi I, and I don't know what he was talking about. I would just like to write this down for you guys as 1 over pi over 2i, alright? And then of course we keep this part, which is I to the x power, but now we see that I don't like to be on the bottom. Let me just multiply by I and I right here. So all in all, we see that this is -1. I'll also bring the 2 to the top, so we get -2 with this I over this pi, and again this times that is the negative right here already, and then I have the I to the x power, and then we are done like this. Now continue to number 14. Integrating I to the x power dx. This right here is not the integral of e to the x but this is right here just a small fix, because the answer to this, you still get I to the x power, but because the base is not e, what we have to do is divide it by natural log of the base, especially the base is a constant. I is just a complex number, so it's still a constant like that. So you just do 1 over natural log of I like this. Well, what's natural log of I? Check out Dr. Peyam's video, you get pi over 2i. So you get 1 over pi over 2i, and then I to the x power stays. But let me tell you, I don't like to be on the bottom. I like to be on the top. So let me multiply the I and I right here. I times I is negative 1, and then you have this 2 in this denominator. Bring that up, so you get negative 2i right here over pi, and then this right here is still I to the x power plus c. And if you check with Wolfgang alpha, this right here will be the answer that Wolfgang alpha will give you. So this right here is legitimate. Thank you. Now, let me show you number 15. Integrating I to the x power dx. Why don't I just do e to the x, right? But let me tell you, when you integrate I to the x, this is not that bad at all, because this right here is the same as just I to the x, but you divide it by natural log of this constant, which is just I. So that's what we have. However, natural log of I, this is just pi over 2i. Why? Because I watched Dr. Peyam's video. So this right here, we just get 1 over pi over 2i, and then we have I to the x power. And now, let me tell you guys a secret. I don't like to be on the bottom. I like to be on the top. So I will multiply by I here and I here. So as you can see, I times I is negative 1. I will put the negative on the top and also put the 2 on the top. Therefore, we get negative 2, and then the I, and then we have this pi, and then we have I to the x power, and then we add a plus c like that. So we are done. Very nice. Now, number 16. We are going to be integrating I to the x power dx. And the quick way to do it is just I to the x, because I is a constant, and then you have to divide it by natural log of that constant, which is natural log of I. And now let me tell you, natural log of I is pi over 2i. How do I know? Because I watched somebody's video. I'm not going to tell you who. You should go figure it out. And then we have I to the x power like this. However, the secret is that I don't like to be on the bottom, I like to be on the top. So I will multiply the I right there. I times I is I squared, which is negative 1. And we have the 2 right here. I will bring the 2 on the top. So we have negative 2. And then this I here over pi. And then this right here is I to the x power. And then we are done. So let's put a plus c. And if you check with Wolfgang alpha, this right here will be the answer on Wolfgang alpha. Of course, you will have a lot more, but I don't want to do that. So, just like that. This is not question 7, this is question number 17, okay? This is horrible. I'm on question number 17 already. Anyway, integrating I to the x power. This is actually really easy, because when you integrate, e to the x, you just get e to the x. But when you are integrating, let's say 3 to the x, you get 3 to the x, but divided by natural log of 3. Here we have I, so you get I to the x, and you divide it by natural log of I. So that's what we have. And now, natural log of I, let me tell you, it's pi over 2i. So I'll put that down right here. And then we have I to the x power. Watch Dr. Peyam's video right here. But the secret is that I don't like to be on the bottom, I like to be on the top. So I'm going to multiply by I here and I here. I times I is I squared, which is negative 1. And we can also bring the 2 to the top. So all in all, we get negative 2. And then the I right here over pi. And then we have I to the x power. And I'm not going to do anything with the exponent. This right here is the answer on Wolfgang alpha. So I have to respect Wolfgang alpha. Now, next question, number 18. We are going to integrate I to the x power dx. This is not that bad at all, even though the base is not e, but it's a constant. So all we have to do is just I to the x divided by natural log of that. And natural log of I is pi over 2i. So all in all, we get 1 over pi over 2i, and then times I to the x power. And we are going to multiply the bottom and the top by I, because I like to be on the top. Here, you will see I times I is negative 1. This is 2. I'll bring the 2 to the top. So we get negative 2. And then with the I right here over pi. And then we have I to the x power plus c, like this. I'm not going to fix the exponent, because this is the answer that you will get on Wolfgang alpha. We have to respect Wolfgang alpha, right? Now, number 19. We have to integrate I to the x power dx. Well, what we can do is, you see, even though the base is not e, but don't be upset, because all we have to do is just divide it by natural log of the base. So we have 1 over natural log of I, like this. and we still maintain the exponential part like that. Now, what's natural log of I? Well, natural, you can go to get it from Cheesecake Factory, but natural log of I right here is equal to 1 over pi over 2i, and then we have I to the x power. However, I don't like to be on the bottom, I like to be on the top. I will multiply I and I here so I can get to the top. Now we get, this is -1, I'll put it on the top, and then I'll also put a 2 on the top. All in all, we get -2, and then we have the I over pi, and then we have I to the x power, and of course, don't forget the plus c, like that. And yes, I did bring my clock, I did bring my clock right here. You guys see, I should have told you guys this about like 40 minutes ago, but oh well. Anyway, number 20, I'll give you guys something special, of course. Number 20, I will do red pen, black pen. So, we are going to integrate I to the x power dx. Well, to integrate this, as you can see, even though the base is not e, but it's a constant, so when we do this, the solution says you have to just divide it by natural log of I. That's all. So 1 over natural log of I, and then you still have I to the x power, but in this case, natural log of I is pi I over 2. So we actually end up with 1 over pi over 2i, or pi over 2, up to you. And then you have I to the x power on the side. However, I don't like to be on the bottom, I like to be on the top. Let's multiply by I and I here. So as you can see, this right here will give us -1. This is 2 in this denominator. Bring that up. We have we'll have -2, and then the I over pi, and then the I to the x power, and in the end, plus c right here, of course. So that is it. Very cool, huh? Now, continue. Number 21. Okay, 40 minutes times. I have to do 4 more times. I will see. We can do it. We can do it. Anyway, number 21, we are going to integrate I to the x power dx. Well, this is just a constant base, so we get 1 over natural log of I, because you know, anything besides you have to divide it by natural log of I. And then this exponential part stays, so that's what we have. Now, let me tell you, natural log of I is just pi over 2i. So this right here is just 1 over pi over 2i, and then we still have I to the x power, but I don't like to be on the bottom. Let me just multiply I and I like this, so I can get to the top. This is -1, and I'll bring the 2 to the top as well, so we have -2i over pi, and then multiply by I to the x power, like that, and then plus c, okay? Oh man, when I did that, maybe you guys knew like how did I put the clock up, but whatever. Number 22, we are going to integrate I to the x power dx. Okay, how can we do this? Well, we can use the formula, because this right here, it's not base e, it's base I, and it's just a constant, so all we have to do is just keep the exponential part I to the x power, but we have to divide it by natural log of I, so we have 1 over natural log of I, like this. However, this right here, natural log of I is pi over 2i, so this is 1 over pi over 2i, and this right here, we have I to the x power like this. But I don't like to be on the bottom, I like to be on the top, so multiply by I, multiply by I. So this right here is going to give us -1, put a negative on the top, and also put a 2 on the top, so we get -2i over pi, and then here we have I to the x power plus c, and this is the answer that Wolfram Alpha will give us, so I will leave it right here. Now, number 23. Hopefully you guys are doing well. I will try not to drink anything, I'll try not to go to the restroom, so I'll try to be hardcore. No food, no water, no stop. Right? Number 23, integrating I to the x power dx. Well, this is an exponential function, technically, right? And then the base is I, it's a constant. So what we have to do is I to the x power, but you divide it by natural log of I like this. But natural log of I, thanks to Dr. Peyam, we know now it's just pi over 2i. So I'll just put on pi over 2i right here. Don't forget, we still have the I to the x power, but we are going to multiply the bottom and the top by I, because that way, that's how we can get to the top. I times I is -1, I will put a negative on the top, and then put a 2 on the top as well. And here we have the I, and then the pi is on the bottom, and then we have I to the x power, and we are done. I'm not going to mess around with this answer, because this is the answer that Wolfram Alpha will give us. Now, number 24, we are going to integrate I to the x power dx. And then we are going to see, this right here is just I to the x power and divided by natural log of I, because the base is not e, So you have to divide it by natural log of whatever the base is. And you can think about if the base was e, you divide it by natural log of e, which is just 1. You are not dividing it, anything special. So that's what we have. And then natural log of I, thanks to Dr. Peyam, we get that's pi over 2i. So this right here is just 1 over pi over 2i. And then we have I to the x power, but I don't like to be on the bottom, I like to be on the top, so multiply by I, multiply by I. So you see this is negative 1, bring that to the top, and bring the 2 to the top. Therefore, we get negative 2i over pi, and then this right here is just I to the x power plus c, like this. Cool, huh? Now, number 25. We are going to integrate I to the x power dx. Well, when we do that, we have to just get I to the x power, and then, the base is not e, so we have to divide it by natural log of I, right? Just like that, natural log of the base. And now, to figure out this, natural log of I is just actually pi over 2i. Very interesting. Be sure you guys go check out Dr. Peyam's video. And then don't forget the I to the x power, but if you want to be on the top, let me show you, multiply by I, and then you can be proud and say, I am on the top now. So we get I squared, which is negative 1, we can bring that to the top as well, and along with the 2, right? So all in all, we get negative 2i on the top over pi. And then this right here is I to the x power, and we're done. I'm not going to fix anything because this is the answer from Wolfgang Alpha. Now, number 26. Let's go ahead and integrate I to the x power dx. Well, this is just like an exponential function, even though the base is I, but it's okay. The answer is still going to be I to the x power, and divided by natural log of I, because again, the base is not e, so you have to do it like this. And now, we have to figure out what L and I is. And let me tell you, this is just pi over 2i. So we get 1 over pi over 2i, and then this is I to the x power. And you see that? We have an I on the bottom, that's no good. I like to be on the top, seriously. So multiply I and I like this. This is going to give us negative 1, and we have the 2 right here. Let me bring that up as well. So we have negative 2i over pi, and then we multiply by I to the x power, and then we are done. So put plus c like this, right? Number 27, perfect number right here. We are going to integrating I to the x power dx. Well, this is just an exponential function, so the answer is going to be I to the x power, but the base is not e, so you have to divide it by the base, which is ln, of course. In another word, we do 1 over ln I like this. And ln I is actually just pi over 2i, so here we get 1 over pi over 2i, and then this is still I to the x power, but let's go ahead and multiply I and I like this, so that way I can be on the top. I times I is negative 1. And you put it on the top, you can also put a 2 on the top. All in all, we end up with negative 2i over pi, and this is I to the x power, and we are all done like that. Whew, so cool. 27. Okay, now I remember. Wow, look at this. So cool. Maybe this is for my screenshot for the thumbnail. Or maybe I do this. I don't know. I don't know which one I should be using. I don't know which one I should be using for my thumbnail. Whatever. Okay, that was 27. Okay, I shouldn't talk too much. Otherwise, I will be, I forgot which number did I do, and then that will suck because I might have to do it again and all that. So I think I'm getting it. I think I'm getting how to do the integral of I to the x power after 27 times. These exercises are so helpful. We can figure out how to integrate I to the x power. It's amazing, right? Okay, so I'm going to just kind of move around. Okay, here, number 28. I want to kind of just play around with that, how many integrals I can fit in on one board. We'll see how many integrals we can fit in. Okay, integrating I to the x power dx. Well, the base is not e, so you have to remember that we get I to the x power but divided by natural log of the base. So that's what we have. But we can do better because natural log of I it's the same as pi over 2i. Pi I over 2. Depends on how you want to say it. 1 over, this is again pi over 2 with I next to it. And then we have I to the x power like this. But you have to watch Dr. Peyam's video so you can figure out this right here, right? And then again, I don't like to be on the bottom. Let's multiply the I top and bottom so I can get to the top. And then we get negative 1, and then we put the 2 on the top as well. So you know we get negative 2 with this I, and then over pi. And then here we have I to the x power like this. So That's it. Cool, huh? Now, number 29. Here we have integral of I to the x power dx. And this is going to give us, well, I to the x power, because this is just like e to the x, but the base is not e. Base is I. It's just like a constant. The only thing you have to do is divide it by natural log of that base. So we have to divide it by natural log of I. And thanks to Dr. Peyam, we all know that this is going to give us pi I over 2. Therefore, I will just put down pi I over 2 like this. And then we have I to the x power like this. And then we have to be on the top. Let's multiply by I right here and there. So we will see that this is going to give us -1, which is going to bring to the top. And then this 2, I can also bring that to the top. So we get -2i over pi, and then I to the x power. And let me tell you, this is the answer that Wolfram Alpha will give you. Put a plus c right here. I just realized I didn't put a plus c right here. I'm sorry. I will put down a plus c right here. Yes. This is why we have to practice integrals many times. Anyway, number 30. Now, let's see, how can I give you guys a special one? Maybe I use purple. Why not? Number 30. Ooh, purple, spooky. Integral of I to the x power dx. Well, we know this is just I to the x power because this is an exponential function, but the base is not e, the base is I, so we have to divide it by natural log of the base, which is like this. And now, let me tell you, ln I, thanks to Dr. Peyam, we all know that's pi I over 2. So this is going to be 1 over pi I over 2, and then we have I to the x power like this. But I don't like to be on the bottom, I want to be on the top. So what we are going to do is, let's just multiply by I here and here. And then as you can see, we have this extra dot here that's no good. Dot will be right here. Now, I times I is -1, we can put the negative on the top, and also the 2 on the top as well. Therefore, we get -2i over pi, and then I to the x power, and then we put a plus c like this. All right, so that's very cool. And yeah, 30 questions and 70 more to go. Let's see, we have to speed up the process because the more you do it, the faster you get, the better you get and all that. And I would like to see if somebody else also do somebody else also does like 100, like one integral 100 times. That's how you can become an integral master, all right? And if you guys are still watching, thank you guys so much. Anyway, integral of I to the x power dx. Now, let me tell you, to integrate this, unfortunately, the base is not e, but it's I. So what you have to do is just go ahead and divide it by I for the base, like this, with an ln. That's all. Very easy, huh? Well, thanks to Dr. Peyam, we all know this is pi over 2i. So we have 1 over, we put the pi over 2, and then I right here, and then we have I to the x power like this. And because I don't like to be on the bottom, I like to be on the top, so let's go ahead and multiply I and I right here. And as you can see, I times I is -1, and then we have the 2, we can also bring that up. So all in all, we get -2, and then the I right here, and also the pi on the bottom like this, and then that's multiplied by I to the x power like this. And this is the answer that Wolfram Alpha will give you. So let me just box this to pay the respect to Wolfram Alpha. Now continue to number 32. In this question here, we are going to be integrating I to the x power. Maybe you guys haven't seen this before. If not, check this out. It's actually just as easy as e to the x, because we are just going to put down I to the x power, but the base is not e, so we just have to divide it by natural log of I. So we have this. And the deal is that natural log of I is actually just pi I over 2. How do I know? Well, I checked Wolfram Alpha already, so you can trust me. So we have pi I over 2 like this for the ln I, and don't forget we still have the I to the x power like this. And I don't like to be on the bottom, I like to be on the top. So let's go ahead and multiply by I and I right here. So I times I is -1, and this is a 2. So bring that up as well. So therefore we get -2i over pi, and then we have I to the x power, and then we add a c to it, and then we are done. Now, moving on to question number 33, we have to integrate I to the x power dx. Well, if you haven't seen this before, let me show you. We are going to just go ahead and put down I to the x power, because this is like an exponential function. But the base is not e. We have to just divide it by natural log of the base. So we get 1 over natural log of I. And we have to go to the complex rule for this, right? But let me tell you, natural log of I is just pi I over 2. So we get 1 over pi I over 2 like this, and then we have the I to the x power like that. And let me tell you, I don't like to be on the bottom, I like to be on the top, and I think you should be on the top as well, seriously. If you want to be on the top, let me know. Multiply by I and I here, so you get I times I squared, which is -1. And you have the 2, so you can bring that up. So you have -2, and then you have the I, and then you have the pi on the bottom, and then you have I to the x power, and you're done. Put a plus c. This right here is the answer on Wolfram alpha, so I just box it right here. Now, question number 34, we're integrating I to the x power dx. Well, I know this is not e to the x, but it's just as easy. Right here, we're just going to have I to the x, but we're going to divide it by natural log of the base, which is like this, natural log y on the bottom. And natural log y is actually just pi over 2. So right here, we get 1 over pi I over 2, and then we have the I to the x power like this. But I don't like to be on the bottom, I like to be on the top, so multiply by I and I right here. And as you can see, I times I is -1. And here we have the 2, so we'll bring that up to the numerator. So in all, we get -2, and we have this I right here. And notice that we have this pi, and then we have I to the x power. So that's it. I'm not going to play around with the exponent, even though you can write this as I to the x plus 1 if you would like. Or you could have done this as I to the x minus 1 if you would like, but I'm not going to do that. I will just leave it to you guys. Okay, number 34, we are going to be integrating integral of I to the x power dx. So to do that, we are just going to get 1 over ln I, because the base is not e, so we have this. And then we have I to the x power. So that's it, seriously. But ln I is just pi over 2, so we have 1 over pi over 2i like this. And then I to the x power. But don't forget, we don't like to be on the bottom, right? So we like to be on the top, so just get I. Each of us is an I. So altogether it's a we. Not weed, okay, seriously, that's horrible. I times I is -1 because that's I squared. So we have a negative right here, we have negative, and put a 2 on the top. And then we have the I right here over pi right here. And then we have I to the x power like this, and then we are done. So put a plus c like this, and we are done, seriously. Okay, very good. Now, number 36, we have to integrate I to the x power dx, like that. And as you can see, this is almost like a e to the x, but it's not quite. Although, it's not, but seriously, it's very easy. You still maintain I to the x because I is a constant. And you have to divide it by natural log of the base, which is just going to be 1 over natural log of I, like this. And thanks to Dr. Peyam, we know ln I is just pi I over 2. So this is going to be 1 over pi I over 2. And then, of course, you put the I to the x like this. But I don't like to be on the bottom. Let me just multiply the I and I right here so I can get to the top. That's how you do it. So you get I squared, which is -1, and you can also put a 2 right here. So we get -2i over pi, and then we have I to the x power, and then we are done. So put a plus c like that, right? And if you wonder if I ever question about my life, I do. But I will show you guys how to integrate I to the x power like this. I will just tell you guys one answer for this, right? So you see that this is almost an e to the x, but not exactly. The only thing you have to do is, because the base is I, it's not e, so we will have to divide it by natural log of that. So natural log of I on the bottom now like this, and then we have I to the x power like this. And now check this out. ln I is actually just pi over 2. So this is just going to be 1 over pi I over 2 like this, and then we have I to the x power like that. But I don't like to be on the bottom, I like to be on the top, so let's multiply by I and I right here and there. I times I is -1, I will have the negative right here, and then the 2 is also on the top, and then we have the I right here, and then we have this over pi, and then we have this I to the x power, and I'll just leave it right here because that's what the answer is on Wolfram alpha, so this is good. Okay, we have all this done now. Now, of course, we will continue. Number 38. Let's see, what question should we be doing? Let's talk about how to integrate I to the x power. I think this is a really good one. This is not integral of e to the x, this is integral of I to the x. It's almost the same. All we have to do is just I to the x. It stays because it's like an exponential part, but you have to divide it by the derivative of, well, not the derivative, it's the ln of that. That's just like a formula. 1 over natural log of I, like this. That's all. If the base is not e, you divide it by natural log of the base. If the base is e, then you divide by natural log of e. It's just 1. It's good. Anyway, this is what we have, but natural log of I is natural log of I, pi over 2i, is 1 over pi over 2i, and then of course let's put on I to the x power like this. And we are almost done. All we have to do is just multiply the I and I here, and as you can see, this is going to give us -1. I'll put it on the top, and we have the 2 also put on the top, so we get -2, and then we have the I like this over pi, and this is just going to be I to the x power like that, and then we are all done. So of course, let's put a plus z. Be happy. Now, number 39, we are going to integrate I to the x power dx. This right here, we know this is almost like an exponential function, so we'll keep it. I, it's a constant in the complex world. And you see that we are just going to have this and then do 1 over natural log of I, because if the base is not e, you just divide it by that. So you have this, and we know ln of I is equal to pi I over 2. So this is 1 over pi over 2i like this, and then of course you have I to the x power like that, but I don't like to be on the bottom, I like to be on the top. So multiply by I times I is I squared, which is -1, and we have the 2 on the bottom right here, so we can bring that to the top. We get -2, and then we have the I right here, and then the pi right here, and then we have the I to the x power like this, and then we're all done. So put a plus c like that. Alright, cool. Number 40. Let me show you how to integrate I plus 1 to the x power dx. Well, of course, this is very easy. We can just go ahead and integrate I to the x power plus 1 to the x power dx. Right? So that's pretty much it. And I think there's a formula which says if the base is a constant, but that's not e, then you have to just keep the exponential part and then divide it by the natural log of the base. So here we get, you keep this, which is I to the x power over natural log of I, and then right here we're just going to add 1 to the x power over natural log of 1 like this, and we're all done. Put a plus c like that. Okay, next question. We're going to integrate 1 plus I to the x power dx. Actually, no, that's not on my PDF. My PDF is something else. Let me have to go check. I am going to think about what should I be integrating. Let's go ahead and integrate I to the x power. This is number 41. You know what's coming. Yes, let's go check. Number 50. This is number 41, so we get back to normal. Okay, integrating I to the x power. Here is the deal. We just have to do I to the x power like this, but we'll have to divide it by natural log of the base, which is natural log of I like this, because the base is I, it's not e. So we have this right here, but natural log of e is pi over 2. So this right here is just 1 over pi over 2i, and then we have I to the x power, and we are going to divide it by, well, we're going to just multiply the top and bottom by I, so I can be on the top. I times I is -1, put a negative on the top, and then we do also put a 2 on the top, and then this is the I, and this is the pi, and then this right here is the I to the x power, and then we are done, just like that. Now, number 42. For some reason, I sound like Iron Man for some reason, I don't know why. I'm going to show you guys how to integrate I to the x power. I think you guys can hear me, right? Yeah. Cool. Now, I don't know why I tell you guys this is not like live chat, but whatever. Anyway, I will show you guys how to integrate I to the x power. Here is the deal. If we have exponential part, but the base is not e, then you do this. You just keep it as I to the x power, but you have to divide it by the natural log of the base, which is 1 over natural log of I, like this. And the deal is that we have to figure out what natural log of I is. To do so, be sure you watch YouTube videos, and you end up with 1 over pi over 2i, like this. And then you have I to the x power like that. And we have to multiply the top and bottom by I, so that we can be on the top, right? I times I is -1, put it on the top, and also put a 2 on the top. We have -2i over pi, and then we have I to the x power plus c, and we are done, just like this. Very nice. Now, number 43, we're going to integrate I to the x power dx. If you guys haven't seen this before, here is the time. This is actually really, really fun. Fun enough for somebody to do this integral 100 times. I to the x power right? Because this is like exponential, but the problem is that the base is not e, the base is I, but it's also a constant. So all we have to do is just divide it by natural log of the base, which is dividing by natural log of I. And now natural log of I is the same as pi over 2. So right here we get 1 over pi I over 2. And then here we have I to the x power. And we are going to multiply the I and I like this and like that, so that I can be on the top. I times I is -1, we will have negative, and then we have the 2 on the top as well. Just bring the 2 to the top. And then we have the I right here, and then this pi is on the bottom. And then we have I to the x power, and then we are done. So let's put a plus c like that. Now, number 43. As a bonus, I'll do another number 43 for you guys. Integral I to the x power. So, after you guys finish watching the video, let me know how many integrals did we do, okay? Integral of I to the x power is just I to the x power over ln I. And this right here, let me tell you, it's actually really easy. It's just 1 over pi I over 2, I to the x power. But we multiply by I and I here. So all in all, we get, this is 2 and that's negative. So we have -2, and then the I like this over pi, and then I to the x power like this, plus c. Told you it's pretty easy. Okay. Now, let's get to the harder one. Let me show you for number 44 on how we can integrate I to the x power. Well, this can be easy or it can be hard. The hard part is that if you don't watch this video, then you don't know how to do it, right? The easy part is once you finish watching the video, you do this easy. I, it's not e, but it's still a constant, so you raise that to the x power, you still end up with I to the x power, but you have to divide it by the natural log of this. So you have to do 1 over natural log of I like this. And then 1 over natural log of I is just pi I over 2. So we get 1 over pi over 2i like this. And then we have I to the x power. And let me tell you the secret. I don't like to be on the bottom, so I would like to be on the top. Multiply I and I. And I times I is I squared. And we get -1. And then we have the 2 right here, so I'll bring the negative on the top. And we have -2. I right here over pi, and then we have I to the x power and put a plus c like that, right? Now, number 45. Let me show you how to integrate I to the x power. This right here is actually on my final exam. So I will show you guys how to do this. The trick is, I will just keep the I to the x power because I is a constant and x is just to the x power. That's nice. But a lot of students forgot about like dividing by natural log of the base, which is like 1 over ln I, and they have to continue by doing this. 1 over, this is the same as pi over 2i because of Dr. Peyam says so. And then this is I to the x power, and we can multiply this by I, multiply this by I. So this is going to give us -1. I'll put that on the top. And then 2 on the top. And then we have the I over pi. And then we have I to the x power. I'm not going to fix any exponent. I'll just leave it like this because this is the answer that Wolfram Alpha will give us. Now, number 46. I will show you guys a hard question. Integral of I to the x power. This right here is just I to the x power. But the hard part is that a lot of students, they will forget about how to divide it by natural log of I. And natural log of I right here is actually just 1 over pi over 2i. And then you keep the I to the x power, but you are going to multiply the bottom and the top by I, so I can be on the top. I times I is -1. And the 2 will be on the top, and then the I is right here. And then you have the pi on the bottom, and then you have I to the x power. So that's pretty much it. We are done. Put a plus c. We are done right here. Very cool, isn't it? Yeah, so pretty when you have so many integrals on the board. Seriously, that's the quote. It's just amazing that you have so many integrals on the board. Wow. Yeah, I'm gonna enjoy this before I erase the board. Wow. Can we fit in another one? Maybe, huh? Let's go ahead and do that. Let me just do it right here so I will enjoy this a little bit more. We are going to integrate I to the x power dx. And let me tell you, we get 1 over natural log of I to the x power. And I don't know how many of you guys are watching, so let me just tell you guys the answer, which is just, this right here is just 1 over pi over 3. I don't know if you guys are watching or not. I'll tell you guys the correct answer is pi over 2i. If you are not watching, you will get this wrong on the test. That's no good. And if you are not watching and you don't know how to be on the top, I will tell you though. Anyway, hopefully you guys are watching. Multiply I and I here. I times I is I squared, which is -1. Put the negative on the top, which is negative, and that's also put the 2 on the top. And then we have the I here, and then the pi here, and then don't forget the I to the x power, and then of course we add the c, and we are done. So now this is more enjoyable than earlier because I have more integrals right here. And take a guess, but take a look. I do have another integral right here. Please don't ask me to do this 100 times. This right here, it's nearly impossible to do it 100 times. Unless I have like 20 hours in a day. Well, 20 hours to spare. But, no. Anyway, take a look. All right, we went over a lot of questions. So be sure you know how to do every single questions right here. And yeah, hopefully you guys see how to do these questions that we just went over. And the study guide is in the PDF to the study guide. The PDF is in the description. Right? And I do have my website, even though I'm sorry, I haven't been updating my website. I'm very sorry, I'm just very busy. You can see why I'm very busy. I don't just do one integral. I do a lot of integrals. How many integrals do you guys do per day? Huh? I don't know. You have to tell me. Do you guys ever have an integral that you can do like a lot of times? I know. I remember that was 47. Okay. Now I'll show you guys how to get to 48. Okay, number 48. Number 48. We are going to be integrating that should entertain you guys a little bit. So, I to the x power dx. How do we do this? Unfortunately, the base is not e, but it's almost similar, okay? All you have to do is just repeat the exponential part, but divide it by natural log of the base, which is e. Can you guys hear that? 1 over L and I. Technical difficulty, okay? However, when it falls, it falls. Please don't fall, seriously. Anyway, natural log of I is pi I over 2. So I will tell you this is 1 over pi over 2i. And then we have I to the x power. And now, let's do it a little bit different. Because sometimes you don't want to use the answer from Wolfram Alpha. Take a look, we have I to the x power over I to the first power. So all we have to do is just subtract the exponents. And of course, we can flip that. So in another word, we get 2 over pi times I to the x minus 1. That's very cool. Look at that, because usually when we anti-differentiate, we have to add 1 to the exponent and then divide it by the new exponent. But here, it seems that we have to subtract 1 to the exponent. Very cool, isn't it? All right, so that's it. Right? This right here is it, right? Now, number 49. Again, I'll show you guys how to integrate I to the x power dx. Well, this is not e to the x, but it's very similar. All we have to do is just I to the x, but divided by natural log of the base, which is just 1 over natural log of I, like this. And now, I will tell you, natural log of I is the same as pi I over 2. So here we have 1 over pi I over 2, multiplied by I to the x power. And now here's the deal. Look at, we have I in the denominator and I to the x power. Of course, we can subtract the exponent. So we get I to the x minus 1 power like this. Very nice, huh? And of course, we can also do the reciprocal. So we get 2 over pi times that. And we are done. And check this out. Don't get mixed up with taking the derivative by bringing the power to the front and all that. Don't do that. You just leave it like this. Seriously, just leave it like that. Okay, I think. Okay, so that's what we have. Now, number 50. And here is a special one. I will do this one in blue to make it slightly more stand out. Okay, so here we go. Integrating 1 plus I to the x power. Well, can we do the same? Yes, we can. This right here is going to be, well, the base is 1 plus I, which is still constant, and you raise that to the x power, and then you are going to divide it by 1, well, divide it by natural log of the base, which is, you have to do natural log of 1 plus I like this. That's it. Okay? So, yes, for number, I will just write this down for you guys just to be nice. Number 40, I have the integral of I plus 1 to the x power dx. This is unfortunately not the same as integral of I to the x power plus 1 to the x power dx, unfortunately. And of course, 1 plus I plus 1, same thing, so yeah. Anyway, this is actually what we have to do, okay? And the deal is that, can we figure out ln of 1 plus I? Sure. Let's go ahead and go to the complex rule for it. 1 is here, I is here, 1 plus I is here, and we have to figure out the distance. Of course, square root of 1 square plus 1 square, which is square root of 2, and this is the r. And then the angle is just, 45, 45, 90 special right triangle, which is pi over 2, pi over 4. So, right here, 1 plus I is the same as square root of 2 times e to the I times pi over 4. And we'll just take the natural log on both sides. Natural log, I feel like eating natural already. We take a natural log on both sides. So natural log of 1 plus I is the same as natural log of square root of 2 plus, well, let me just show you guys all the work, times e to the I pi over 4. But here's the deal. This is the product of two things. So we can do natural log of square root of 2 plus natural log of e to the I pi over 4. Very nice, isn't it? This and that cancel out nicely. Very good. And as we all know, square root of 2 is the same as 1/2 power. You can bring the 1/2 to the front. So we get 1/2, and then we have natural log of 2. And then this right here is I pi over 4. So this is pretty much it for the natural log of 1 plus I. So what I will do is I will actually just come here and I will just write down the complex number in the standard form. So this right here is equal to 1 over, that is just this, which is 1/2 natural log of 2. And this is just a real number, right? 1/2 natural log of 2. I will write it down bigger so we can all see it. Okay, so we have 1 over 1/2 natural log of 2, and then plus pi over 4i. Okay, we usually put the I at the end. And this time I like to be on the bottom, so I'm not going to do anything weird. And then multiply by 1 plus I to the x power. And of course, we're done. So we put plus c. I want to be on the bottom this time, so I'll just leave it like that. That's the integral of 1 plus I to the x power. This was just wrong. Okay, that was number 50. We are halfway done, so that's good. Now, let's see, what can we do for number 51? Of course, we are going to integrate this one. It's a famous one, the integral of I to the x power dx. Well, when we integrate that, this is just going to give us I to the x power over natural log of I, because the base is just I. And natural log of I, it's nicely equal to pi over 2i, like this, and then we have I to the x power. And now, of course, we can subtract the powers. and then flip that, so we get 2 over pi times I to the x minus 1 power, and then we're all done, so put a plus c like this. Now, number 52. I will show you guys how to integrate I to the x power. If you haven't seen this before, here is the time. This is very cool. You don't see it anywhere else, maybe just on my channel. I don't know if you have seen it back in Algebra 2 or whatever, but anyway. This right here is I to the x power, but you have to divide it by the natural log of the base, which is going to be 1 over natural log of I. And let me tell you, this right here is pi I over 2. So we have pi over 2i like this, and then we have I to the x power like that. And here's the deal. Of course, we can just do the reciprocal, so we get 2 over pi, and then subtract the power, so we have I to the x minus 1 power, and then we're all done. It looks like a derivative, huh? You can subtract the 1, but no, it's nothing to do with derivative. Well, it's the antiderivative, but whatever. Anyway, I'll show you guys how to integrate I to the x power for the next one. Here, we get I to the x power, and then we have to divide it by natural log of the base, which is the natural log of I like this. And let me tell you, this right here is pi I over 2. So I think we have to do this much faster because the clock is literally ticking. Anyway, this right here, you do the reciprocal is 2 over pi, subtract the power, we get I to the x minus 1 power, and then we are done. So put a plus c. That's it. Very cool, isn't it? Now, 54, isn't it? Integral of I to the x power dx. How do we do this? Well, this is an exponential function, so you stay, right? And the base is just a constant. And then we are going to do divided by natural log of the base, just like that. And then this is going to give us this part as pi I over 2. So this is 1 over pi over 2i like this. And then you have I to the x power. You can subtract the powers and you can flip that. You get 2 over pi. And this is going to be I to the x minus 1 power plus c. Yeah. It's like this. This is the I, this is the C. I don't know. Number 55. We are going to be integrating I to the x power. So let's see how this is going to go. It's actually pretty easy. We are going to just maintain the I to the x power, but the base is I, so we have to divide it by the natural log of I. And natural log of I, hopefully you guys all know this is pi I over 2. It's such a famous number, so be sure you guys just watch the video if you don't know what it is already. And then of course you have that. And now pi over 2, flip that, so you have 2 over pi minus the exponent, so we get I to the x minus 1, and we're all done. So put a plus c like this. Now, 56, right? You feel excited? I'll show you guys how to integrate I to the x power dx. Well, for this one, I will have I to the x because that's the exponential part. We have to divide it by the natural log of the base, which is ln I like this. And then we see that this right here is pi I over 2, so we get 1 over pi over 2i, and then this right here is I to the x power. And as we can see, we can do the reciprocal of the pi over 2, which is going to be 2 over pi, and subtract the powers, so we get I to the x minus 1 power, and then put a plus c, and then we are done. That's all. Now, 57, integral of I to the x power dx. Well, in this case, we have I to the x power, but the base is not e, so we have to divide it by natural log of that base, so it's 1 over natural log of I. And as we all know, this right here is just going to be pi over 2i. So this is going to be 1 over pi over 2i, and we have I to the x power right here, and do the reciprocal, we get 2 over pi, and we can just subtract the powers, so we get I to the x minus 1 power, and then we are done. So we put a plus c like this. Very cool, huh? Now, I'll show you guys number 58 right here. So for number 58, we are going to integrate I to the x power, and this right here, it's going to be, I will have to maintain I to the x power, and we have to divide it by the natural log of the base, because the base is not e, so we have this. And I to the x is just pi I over 2, so this is 1 over pi I over 2 like this, and then I have I to the x power like that. And check this out, we can subtract the powers, so this is just going to be I to the x minus 1 power, but we can do the reciprocal on this, which is just 2 over pi, and then we're all done, so put a plus c like this. So this is my I, this is my c. Now, number 59, we are going to be integrating I to the x power dx, and this right here is just I to the x, and then divided by natural log of the base, which is natural log of the I like this, and this is going to give us 1 over, and this right here is just pi I over 2. So I just put down pi over 2 I, and then we have I to the x power. And you see that this is pi over 2 right here in the denominator, so we do the reciprocal, so we get 2 over pi, and then subtract the power, so we get I to the x minus 1 power, and then put a plus c like this. That's it. And even though you don't see this on Wolfram Alpha, but this is also just as legitimate. Now, number 60. This one here. Give you guys something special. I will show you guys how to integrate 1 to the x power dx. And of course, I think you guys have seen a video, somebody integrate I to the x power, and that person thinks blackpenredpen. If you guys don't know what the video is, be sure you help me to comment down below and help each other to find that video. He integrate I to the x power. Let me show you guys how to integrate 1 to the x power right here. Well, by similar strategy, the base is not e. Even though in Chinese, this is also e, but in English, this is 1. Anyway, the base is 1, it's not e. So you maintain this, which is going to be 1 to the x power, but you have to divide it by natural log of the base, like that. And technically, we are done. And that's it. Why not, right? And perhaps right here, let me just add a fish to it, like an evil fish, or like a sad fish, like that. Right? So that's how you integrate 1 to the x power with a fish. Now, number 61. I will show you guys how to integrate I to the x power dx. Well, as you can see, I is a constant. Well, to the x power, you will have I to the x power, but divided by natural log of the base, which is 1 over natural log of I. And we all know this right here is pi I over 2, so we get 1 over pi I over 2 like this, and then multiply by I to the x power. Subtract the powers, we get I to the x minus 1 power. Reciprocate this, which is 2 over pi, and then we're done, so put a plus c like that. So we are done. Now, number 62, we are going to be integrating I to the x power dx, and of course this right here, we get I to the x power, and then divided by the natural log of the base, and we all know natural log of the I is just pi over 2i like this, and we all know I to the x is right here, and subtract the powers, we get I to the x minus 1, do the reciprocal right here, so we get 2 over pi here, and then we put a plus c, and we are done. Okay? Now, number 63, we are going to integrate I to the x power dx, and I will show you the quick way. I to the x, keep that, divided by natural log of the base, which is going to be like this. And I will also tell you, natural log of I is the same as pi I over 2. And of course, you can keep adding the 2 pi to it, we'll subtract 2 pi to it, but just worry about the first number here. So we get 1 over pi over 2i, and then this is I to the x power. Well, do the reciprocal and then subtract the power, so we get 2 over pi, and then this is I to the x minus 1 power, and then put a plus c, and then we are done. Like this. Very good. Now, number 64, we are going to integrate I to the x power dx. Now, I will look at you guys. Let's see. This is equal to, well, we have I to the x power, and we have to divide it by the natural log of I. So this right here is equal to pi I over 2. So this is 1 over pi over 2i, and then we have I to the x like this. Well, we can do the reciprocal right here, which is 2 over pi here, and then I to the x minus 1 when you subtract the power, so put a plus c. Right? Kind of. Okay, number 65, integral of I to the x power. Here, we are going to have I to the x power, but don't forget, the base right here is not e, so we have to divide it by natural log of the base. So we have to do 1 over natural log of I, and 1 over natural log of I right here is equal to 1 over pi over 2i, and then we have I to the x power, and you can just reciprocal that, and then this is just I, and then x minus 1 power. Like this. Okay? Now, number 66. I'm not going to do 65 again. Number 66. Integral I to the x power dx. This looks like a 6. Seriously, S-I-X. Anyway, this right here is I to the x power. You state that. And then the base is I is not e, so be sure you divide it by natural log of I. And natural log of I, the first answer for that is just pi I over 2, so we'll just put down pi I over 2 like this, and then we'll have I to the x power. And do the reciprocal right here, which is 2 over pi, and then subtract the powers, which is I to the x minus 1 power, and then we are all done, so put a plus c at the end, like that. Now, number 67, I will show you guys how to integrate I to the x power, and this right here is equal to, you keep the exponential part, which is I to the x power, and then you have to divide it by the natural log of I. So it's 1 over natural log of I. But this right here, as we all know, it's pi I over 2. So this is 1 over pi over 2i, and this is I to the x power. And we can subtract the powers, do the reciprocal of that, which is 2 over pi. And this right here is I to the x minus 1 power, and then put a plus c. And then we are done. Okay, number 68. Here we have to integrate I to the x power, and this right here, let me tell you, we will just get I to the x power because that's the exponential part, and then the base right here is just I, it's not e though, so we have to do 1 over natural log of the base, which is natural log of e. Natural, okay, and then this right here is just going to be 1 over, natural log of I is pi I over 2 like this, and then we have I to the x power, and this right here, do the reciprocal, which is 2 over pi, and then you subtract the powers, which is I to the x minus 1 power, and then put a plus c, and then we are done, like that. Okay, so that was number 68. Now, we are going to get to a number that's going to make a lot of guys happy for some reason, the 30 reason, I guess, whatever. So hopefully, you guys are doing okay. If you guys are studying for your final, here's the trick, right? Here's the deal. This is how you should study. Sometimes when you're doing an integral, it's a long process. And a lot of students, they just finish doing the integral and then they just put it away and think they are all done. But no, it's a good idea to go back and then cover the work that you did and then try to redo the work on your own. Try to redo the work from scratch. If you can really do it, that means you are really getting it. It's the same as doing proofs. I remember when I was an undergrad, for example, we have to prove that there are infinitely many primes. I pretty much redo the proof from scratch about 5, 6, 7 times in order for me to really prepare for the final exams and all that. Yeah, not kidding, okay, not kidding. And please don't ask me to do that proof 100 times, so that's overkill, but like, that's how you should study, okay? Anyway, number 60. Well, I'll show you guys the integral of I to the x power dx. Here's the deal. Base is I, so you have to divide it by natural log of the base, which is like this, 1 over natural log of I. And then we have I to the x power. And as we all know, this right here is pi I over 2. So we get 1 over pi I over 2 like this. And then we have I to the x power. Do the reciprocal, we get 2 over pi, right? The reciprocal is just 2 over pi. And then we have I, subtract the powers, which is x minus 1. And this right here, even though it's not the answer that you will see on Wolfgang Alpha, but let me tell you, it's still legitimate. It's really good. And then I, if I is on the bottom, pick it up. You have that in the exponent now. That's all. I know some of you guys might be looking at this for the clock, but anyway, number 70, and let's do another fun one. Okay, number 70, I will show you guys how to integrate x to the x power dx. Well, thanks to blackpenredpen, we all know we keep this, which is x to the x power, and then we do 1 over natural log of the base, which is x. So yeah, that's it. And then natural log of x is just natural log of x. Up to you how do you do it. So put a plus c. Well, let's put a plus fish. Again, or plus the evil fish. It's sad, you guys should know why. But anyway, if you want to be legitimate, if you want to see how to integrate this from 0 to 1, check out Dr. Peyam's video, right? So, yeah. Anyway, that's just a bad joke. Anyway, number 70, legitimate. Okay, I will not cheat. This is integral of I to the x power. What we are going to do is we have I to the x and then divide it by natural log of I. This is legit. This is not, because earlier here, the base, it's x, it's a variable. It's a function, x. So that's not legit. You cannot just divide it by natural log of x. No, don't do that. This right here is okay because I is a constant, so this is legit. Now, natural log of I is pi over 2, so we get 1 over we get pi over 2i, and then we have I to the x power, and do the reciprocal of that, which is 2 over pi, and then subtract the powers. This is I to the x minus 1 power. That's it. We are done. So put a plus c like this. We are done. And as you can see, I'm just using my hand to clean the board, so that's why my hand's dirty. But usually, but in fact, it's pretty clean. The markers are good. Export markers for the wing, seriously. Now, number 71, we have to integrate I to the x power dx. Well, we have to just maintain I to the x, but because the base is I, so we have to divide it by natural log of I, so it's 1 over natural log of I, and natural log of I is pi over 2, so we get 1 over pi I over 2 like this, and then we have I to the x power, and then you have to subtract the power and do the reciprocal of that, which is going to be 2 over pi, and then this is going to be I to the x minus 1 power and then plus c, and then we are done. Now, I'll show you guys how to do number 72. Integral of I to the x power. This right here, because it's exponential, so we keep that, but you have to remember the base is not e, so you have to divide it by natural log of the base. We'll have 1 over natural log of e, not much enough, 1 over natural log of I. And then this right here is pi over 2, so we get this is 1 over pi over 2i, and this is I to the x power. And of course, we can do the reciprocal of that, which is 2 over pi, and then subtract the powers. So we get I to the x minus 1 power, and this has nothing to do with the power rule for the derivative. This is just how it is. Although you don't see the answers on Wolfram Alpha like this, but they are still this answer is still legit. Anyway, I will show you guys how to integrate I to the x power right here. This right here, how can we do it? Well, it's not e to the x, but it's almost the same. You just repeat whatever to the x power. If the base is a number, you just repeat that. And you divide by I, like this, natural log of I. So you have that, and then natural log of I is pi over 2. So you end up with 1 over pi over 2i, and then you have I to the x power like this. Do the reciprocal of that, which is 2 over pi, and then subtract the powers. You get I to the x minus 1, and then you are done. So put a plus c, and we are done. Now, let me show you how to do the integral of I to the x power. Well, this right here, exponential, the base is just a constant, so you just have I to the x power, but you are going to divide it by natural log of the base, which is natural log of natural log of I. And this right here, natural log of I is equal to 1 over pi over 2i, and then we have I to the x power. Well, do the reciprocal of that, which is 2 over pi, and then subtract the powers, we get I to the x minus 1 power, and then of course we're done, so just put a plus c, just like that. Now, I will show you guys how to do number 75. So hopefully you guys all download the file, so you guys can see the question, so that's how you guys can follow along. So for this question, we are going to integrate I to the x power, and then we are going to divide it by the base. Because the base is constant, we just have to do 1 over natural log of I. And 1 over natural log of I, this right here is 1 over pi over 2i, because that's what ln I is. And this is I to the x power. And this is going to be reciprocate that, which is 2 over pi. And then I to the x over I to the first, which is the same as I to the x minus 1. And then we are done. Put plus c, like that. Now, number 76. If you guys watch basketball, let me know if you guys like the Philadelphia 76ers or not. Let me know. I used to like Allen Iverson a lot. And now, of course, Joel Embiid and all the new people, right? Depends on your age, of course. Anyway, integrating I to the x power dx. Well, it's just going to be dividing by the natural log of I, because the base is not e, right? It's just a constant I, and you have I to the x power. It's just like that, very easy. And then ln I is pi I over 2. I think that's how it is. I'll just write that down. If I make a mistake, nobody's watching anyway. And then right here, I to the x power is like this. And then right here, do the reciprocal, we get 2 over pi, and then subtract the powers, we get I to the x minus 1 power, and then put a plus c. And then right here, we are done. Number 77. Now, we are going to integrate I to the x power dx. Well, this right here is almost the same as exponential, so I'll put down I to the x power, and I'll do 1 over natural log of I, because again, the base right here, it's a constant, it's not e, so you have to divide it by natural log of I. If you have the e to the x, you divide it by natural log of e. Natural log of e is just 1, so it doesn't really matter. So now that's what we have, and as we can see, natural log of I is just pi over 2. So right here, this is just going to be 1 over pi over 2i, and then this is I to the x power. Do the reciprocal of that, which is 2 over pi. Subtract the exponents, we have I to the x minus 1 power, and then we are done. So put plus c. We are done like that. Very nice, huh? Now, moving on to number 78. Woohoo! Number 78. We are going to integrate I to the x power. Now, when we do that, we get the following. This right here is almost exponential, so just keep that because the base is constant, and you just have to divide it by natural log of the base, like this. And then natural log of I, be sure you guys watch Dr. Peyam's video, you will end up with pi over 2i, and then you have I to the x power. Do the reciprocal of this, you get 2 over pi, and this right here, subtract the exponents, you get I to the x minus 1 power, and in the end you are all done, so put a plus c like that, just like this. Now, number 79, integral of I to the x power dx. This right here, it's the same as saying I to the x power and then divided by natural log of I, and this right here, this is the same as pi I over 2. So we get 1 over pi over 2i, and then you have I to the x power. Do the reciprocal here, so you have 2 over pi, and subtract the exponent, you have I to the x minus 1 power, and then put a plus c, and then we are done. Just like that, very nice. Now, number 80. I'll show you guys a legitimate one, okay? But let me just kind of fix this question a little bit. Let's do the integral of I dx, and then raised to the x power. Can we do this? Yes, we can. This is how. Right here. Just do this inside out. Of course, in the x world, the integral of I is just ix. So the inside is just ix. And the truth is, when you integrate that, you should have put down the plus c right away. So go ahead and put down the plus c. We're done. But somebody wants us to take this to the next level. In another word, raise that to the x power. That's it. Of course, if you want to do more crazy stuff, you can use maybe the binomial theorem to do something crazy, but I'm not going to do that with you guys. There is a video, right? You can watch my video, a plus bi raised to the c plus di video. You guys can check that out. Who made it? Somebody named blackpenredpen. So I think it's pretty good. So go watch it if you have some time. Okay, next I will be integrating I to the x power. To do this, we will get I to the x power and then divide it by natural log of the base. And natural log of the base is pi over 2. So we get 1 over pi over 2i and I to the x power right here. Do the reciprocal here, which is 2 over pi, and then subtract the exponents is I to the x minus 1 power, and we're all done. So we put a plus c at the end. So this right here is it. Here we have to integrate 82. Right? Well, I mean, you don't integrate 82, you integrate I to the x power for the number 82. Okay, this is almost like e to the x, but it's not. All you have to do is I to the x and divide it by natural log of the I, the base. And natural log of I, we can actually do that, so we'll do it. So this right here is equal to 1 over pi over 2i, and this is I to the x power. Do the reciprocal here, which is 2 over pi, and then subtract the exponents, which is I to the x minus 1 power, and then you are done. So put a plus c like that. Very cool. 83, we are going to integrate I to the x power dx. And as you can see, right here, this is almost exponential, so I will have I to the x power, and then we have 1 over natural log of I. And the deal is that this right here, it's the same as pi over 2i. So I'll put that down, and then we have I to the x power. And we are going to do the reciprocal for that, so you have 2 over pi, and then subtract the exponent. This is I to the x minus 1 power, and then we're all done, so put a plus c like this. That's it. Now, I'll show you guys how to do the number 84, which if you guys look at the handout, it's going to be in the integral of I to the x power dx. And then when you integrate that, you keep I to the x power right here, and then you have to divide it by the ln of the base, which is natural log of I on the bottom now. And you get this. This right here is 1 over pi over 2i, and then this right here is I to the x power. And you do the reciprocal right here, and you get 2 over pi, and then you subtract the exponent, you have I to the x minus 1 power, and then plus c, like this. Alright, now I will show you guys how to integrate number 85. This is a really difficult one. I to the x power. If you take this to like algebra students, they have no idea what this is going on. If you take this to like a I don't know, man. Seriously, it's hard. But don't worry, because you guys are watching this video. I think after this video, you guys will know how to integrate this right here. And all the other questions on the handout as well. Integrating I to the x power. And by the way, if you guys are watching, right now is 1:43:30, right? That's a timestamp. Give me a timestamp. I will heart you. Thank you. I'll reply for sure. I'll say thank you so much. Anyway, I is a constant. You have to just divide it by natural log of I, like this. This right here is pi I over 2. So we get 1 over pi I over 2 like this, times I to the x power. Do the reciprocal of this, which is 2 over pi, and then subtract the exponent, which is I to the x minus 1 power, and then you are done. So put a plus c. So that's it. Cool. Now, let's look at number 86, which is integral of I to the x power dx. Now this is seriously like 6. This right here, I to the x power, because this is like exponential, I is a constant, you keep it, and the exponent still x. But because I is not e, so you have to divide it by natural log of I. And for natural log of I, be sure you guys go check out Dr. Peyam's video. You end up with pi over 2. This is going to be 1 over pi over 2i like this. And then you have I to the x power. And then do the reciprocal right here, which is 2 over pi. And then subtract the exponents. We get I to the x minus 1 power. And then we're all done. So put a plus c like that. Cool, huh? Now, I'll show you guys how to integrate number 87. Integral of I to the x power dx. Oh my god, this is crazy, this is hard, this is dangerous, but it's not that bad at all. Let me show you how. Because this right here is just I to the x power divided by natural log of I. Again, okay? Again, right here, natural log of I, you have to figure out what that is. Let me tell you though. It's pi over 2i. How do I know? Because I watched Dr. Peyam's video. I'm subscribed to his channel, right? So I have this. And then over here, you can do the reciprocal, which is 2 over pi. And then subtract exponents. You get I to the x minus 1 power plus c. We are done. So cool, isn't it? Oh my god, this is just purely beautiful. Okay, I think that would be my thumbnail. Alright, so hopefully you guys all like this one integral 100 times series. Yes, I will do 100 series for you guys, especially if you are taking Cal 2. That's my goal within like a week or so. Hopefully, that's the deal. And then for my students, if you guys are watching this, or for my Cal 2 students, I will be doing that for you guys to prepare you guys for my final exam and all that, okay? So number 88 will be next. Number 88. We just have a few more to go. It's not that bad at all. Feels so good whenever we get to this stage in our life. Okay, number 88. And then the marker is still going strong. This is just purely amazing. Number 88 is I to the x power that we have to integrate. This right here, we know I is not e, but it's still a constant, so you can just write down I to the x power, but you have to remember to divide it by natural log of the base, which is natural log of I, and you have to know that natural log of I is pi r over 2. So this right here is 1 over pi over 2 like this, and I pi over 2, same thing, right? And then you have I to the x power like this, and then you are going to reciprocate that, which is 2 over pi. Subtract the exponents, you get I to the x minus 1, and then we are done. That's it for this integral, like this. Now, let's do number 89. We have the integral of I to the x power dx. This right here is 1 over natural log of I, because the base right here is I, it's not e. So you divide it by natural log of the base, and then the exponential part repeats. And this right here, natural log of I, it's the same as pi over 2. It's a famous number because Dr. Peyam made the video on that already, and then you can just continue. And now we're done with the integration steps. To fix that, reciprocate that, which is 2 over pi, and then subtract the exponents, we get I to the x minus 1 power, and then we are done. Plus c. That's it. Okay, number 90. So here's number 90. How would you differentiate I to the x power? Let's talk about that. Let's go ahead and differentiate I to the x power. Cool, huh? Well, I don't know how to do anything with base I yet for differentiation. I just know how to deal with the e. Therefore, let me write this down as differentiating e to the natural log of I like this. And of course, right here we still have the x like that. So just make the change. However, here we are going to differentiate e to the something. So we are going to repeat that first, which is e to the x times ln I. Derivative e to the, however, this part right here repeats. E to the x ln I repeats. Good. But the chain rule says we have to multiply by the derivative of this. So this time we have to multiply. This is the chain rule. Usually we do the Lu chain when we integrate, but that's the days for integrations. Right now we have to differentiate. Chain rule is a deal. Derivative of this is natural log of I, like that. Now if you look at this part, this right here is just the same as that, which is the same as that. So we know this right here is just precisely I to the x power, I to the x power. But as you can see, we have natural log of I again. Of course, that's pi I over 2, like this. This time, we can add the exponent, and then we'll end up pi over 2, and then add the exponents, we will end up I to the x plus 1. It's so bizarre, huh? Because I bet a lot of you guys want to bring the power to the front and minus the 1 to the power. No, it has nothing to do with that at all. Pi over 2 times I to the x minus 1 power. Haha, got you. Huh. Now we'll continue. Number 91. Okay, let's see how many we can fit in. Let's do this. Let me just try to do the rest of the questions right here. Number 91, I to the x. We have to first divide it by the natural log of I, because I think there's a video that somebody just teach you guys that way, so you follow along, right? So you do this. Natural log of I is 1 over pi over 2i, and then we have I to the x power. Do the reciprocal right here, which is 2 over pi, and then subtract the exponent, which is I to the x minus 1 power, and we're done. So put a plus c like this. Cool. Now, number 92. We have to integrate I to the x power. How can we do that? Well, this right here, we get I to the x power, because that's the exponential part, but I is a constant. We have to divide by natural log of that, right? So it's 1 over natural log of I natural. I in the natural log is pi over 2i. So this right here will give us 1 over pi over 2i, and this right here is I to the x power. Do the reciprocal of this, which is 2 over pi, and then minus minus for the power, so we get I to the x minus 1 power, and then we're done. So put a plus c right here. Oh my god, did I forget about to put down a plus c right here? Mistakes already made. I don't know. Number 93 right here for you guys. Integral of I to the x power. Well, that looks like an exponential function, but it's not e to the x. It's okay though. I think we can still just do I to the x power, but we just have to remember to divide it by natural log of the base. The base is a constant, it's just I, so we have natural log of I, like this. And now, natural log of I is pi over 2, so we get 1 over pi over 2i, and then we have I to the x power. Do the reciprocal right here, which is 2 over pi. Subtract the powers, I to the x minus 1 power, and then we are all done, like this. Continue, we get 94, which is the integral I to the x power dx. Well, to do this, you see, we don't have e to the x power. It's not that bad at all, because right here we can write I to the x just like this. It repeats. The base is a constant. All you have to do is divide it by natural log of the base, like this. And the natural log of I is pi over 2. So we get 1 over pi over 2i, pi I over 2. Okay? And then we get I to the x on the side as well. Don't forget about that. Take the reciprocal right here, which is 2 over pi, and then subtract the powers, which is I to the x minus 1 power, and then we're all done. So put a plus c like that. Now, 95. Don't you guys feel the excitement? We're almost done with the worksheet. Integral of I to the x power dx. This right here, I to the x stays, because that's the exponential part, but I is a constant, and it's not e, so you have to divide it by natural log of I. And we know natural log of I is pi over 2, which is 1 over pi over 2i, like this. And then I to the x power. And then do the reciprocal of the pi over 2, which becomes 2 over pi. And then this over that, which is the same as I to the x minus 1 power, and then plus c, like that. And now we'll continue. 96. Integral of I to the x power dx. Well, for this one, we have to have I to the x power. And don't forget, because I to the base, it's not e, we have to divide it by natural log of the base, which is natural log of I. And natural log of I is pi I over 2. So we get 1 over pi over 2i. Let's just put it down this way, and then we have I to the x power like that. And then do the reciprocal here, which is 2 over pi, and then subtract the power, we get I to the x minus 1 power, and then put a plus c like this. Very cool, huh? Now, 97. We are going to be integrating I to the x power dx. How do I do this? Well, that's like e to the x. Just write that down, but the base is not e, so we have to divide it by natural log of I, the base. And natural log of I is pi over 2, so we have 1 over pi over 2i like this, and then we have I to the x power. And we can do the reciprocal of this, which is 2 over pi. And then we have to subtract the exponents, which is I to the x minus 1 power, and then we are all done. So it's like that. Very nice, isn't it? Now, I will do the 98 right here. We have to integrate I to the x power dx. This right here, we get, this right here stays I to the x power, but the base is I, it's not e. So we have to divide it by natural log of I. And we know natural log of I is pi I over 2. So we get this is 1 over pi I over 2, and this is I to the x power. Do the reciprocal of this, and subtract the exponents, we get 2 over pi, and this is I to the x minus 1 power, and then we are done. So we can put a plus c like that. Okay, number 99. Integral of I to the x power. Shall I just, no, I'm not going to make it. So let's focus. This right here, we get I to the x power, because the base is a constant, x is the power right here. And don't forget, you have to divide it by natural log of the base, which is like this. And the natural log of I is pi over 2. So this right here is 1 over pi over 2i, and then you have the I to the x power. Take this and do the reciprocal, which is 2 over pi, subtract the exponent, which is I to the x minus 1 power, and then we're all done. So put a plus c like this, right? And I think by now, a lot of you guys will just like skip to the end, which is around this time. So hi. If you have skipped all the exercises we did, you are missing out. You should go back and rewatch the whole thing. We did a lot of integrals today. So, you are missing out. Please go back to watch the video. But please give me a like to the video, because as you know, I spent a lot of time working on this video for you guys. For entertainment purpose, for education purpose, up to you. I'll show you guys the merits of mentality as well. This is also the Bruce Lee spirit, right? So I'm paying my respect to Bruce Lee, of course. Okay, ladies and gentlemen, number 100. We are going to be integrating I to the x power dx. Well, let me just add 1 to the power, because we have the power right here, right? So we add 1 to the power and divide it by the power, which is x plus 1. We end up with 1 over x plus 1, and then I to the x plus 1 power like this. And we are done. Put a plus c. Oh, this is like an evil fish again. Let me just do like a shark, actually. This is like a shark. And then it's like a big mouth. Like this. And the eyes. What's wrong with this? This is totally wrong, okay? No, don't do it like this. 100, legitimate one. Let me show you. Integral of x to the i's power dx. Now, can we do it? Yes. Here's the deal. I will add 1 to the power because the power is a constant. X is the base. You can do the reverse power rule, right? Reverse power rule. Add 1 to the power and divide it by the power, which is 1 over I plus 1, like that. Here, you actually get 1 over I plus 1, and then we have x to the I plus 1 power. This right here is legit. Okay, this right here is actually legit. And of course, you are done plus c. But we are not done yet because I don't like to be on the bottom. How many times do I have to tell you guys that, right? This is the 100th integral already. So what we have to do is just multiply the top and bottom by let's write this down as 1 plus I. Okay, 1 plus I. It should be okay. You guys can see that. And then I'll multiply this by 1 minus I on the bottom and 1 minus I on the top. So that I can actually get this. Right here, you can just do 1 square minus I square. I square is negative 1, where you minus negative 1 is the same as plus 1. 1 plus 1, I believe. Oh my god, that should be... It's like 1 Oreo plus another Oreo is 2 Oreos. So on the bottom here, we have over 2. And on the top, we have 1 minus I like this. And here we have x to the I plus 1 power. And here, we are all done. This right here, again, it's not good at all because x is in the power. We cannot do that when x is on the bottom right here. This is okay. So be sure you don't ever make this mistake. This is question number 100. Feels so good, feels so good, feels so good. Yeah. By the way, this is just like a note. If you do it this way, you can actually figure out the integral of sine of natural log of x dx, and also natural log of cosine, sine of natural log of x, and the integral of cosine of natural log of x dx. By using this right here, you can actually figure it out. And I do have a video on that already. I will link that in the description for you guys. Oh my god. Cool. Of course, I have a bonus for you guys. We're not done yet. Number 101, like this. Well, I feel so bad that I don't have any numbers for you guys. So for number 101, let's go ahead and integrate. Let's do, okay, I to the x power dx. But I will just go from 1 to 2, like this. Anyway, here we go. Yeah, 1 to 2 will work. Let's see. When I integrate this, I get I to the x power over natural log of I. Because again, I, it's not e. So you have to divide by natural log of I, the base. And this right here, I believe it's pi over 2. So this is 1 over pi over 2i like this. And then we have I to the x power. And then in the end, I'll plug in the numbers. Here we have the reciprocal, which is 2 over pi, and then we can just do I to the x minus 1 power like this. Yeah? And then we have to just plug in. So go ahead and plug in 1 and plug in 2. 0 doesn't, well, 0 works as well, but I'll leave that to you guys. Okay? 0, just do that. Okay, actually, if I plug in 1, I to the 0, what's I to the 0? It's not 1. What is it? Anyway, let me just write this down right here for you guys. Here we have 2 over pi, and then I will have I to the 2 minus 1 power, like this, which is legit. And then we have to take that, and then minus, putting 1 right here, so we have 2 over pi, and then I to the 1 minus 1, like that. We have to figure out what's I to the 0th power. Oh man, I have to do it right here. What's I to the 0th power? Well, let's see. We know I to the x. We don't like to work with space I. We like to work with space e. So this is I. And if you write it as e to the natural log of I, and then we have the x like this. This is still going to give us 1. That's good, because if I put down I right here, if you're putting 0 right here for the x, this is going to be just e to the 0 times natural log of I. That's good, so this is still 1. No problem. This is still 1. But what if we have 0 to the i's power? This right here does not exist. It's undefined. And of course, you can watch my other video for that. Okay. So 0 to the x power, be sure you guys go check out the other video. So this right here is 1, so we have 2 over pi. And this right here, all in all, we get 2 over pi I minus 2 over pi. Yeah, so in fact, I will actually write it down as the standard form, namely minus 2 over pi. This is the real part. And then this is the complex part, which is plus 2 over pi times I. Whew. Very, very good. Very, very good. And again, you can try to figure this out. Try to argue why this is not defined. This is 1. This is the jet. You can do something like this to figure it out. I will leave that to you guys. And this is the last one along with this for you guys. Man, I'm done. Alright, so right here, hopefully you guys all like this. Again, one integral 100 times. And please give this video a like and leave a comment down below and let me know which integral would you like to see me integrate 100 times. But please don't torture me. Some integral I can actually finish within the 2 hour will be so. Alright, so please give me a like. Thank you guys so much for watching. And as always, that's it. Thank you guys so much for watching. Okay, thank you. Bye. As always, that's it.